In order to understand Lab 2, we must recall Lab 1. In Lab 1, we manipulated tapes in order to give them an excess charge, and then observed how they interacted with one another, as seen in the image in the upper right-hand corner. I've included my observations and results from that experiment in this slide. It's important to note that in that experiment, our assumptions were that we treated the long tape as if it were a point charge, with all of the charge concentrated at the center of the tape. In this lab, we are now instead assuming that the tapes have the same amount of charge, with the charge evenly distributed along the length of the tape. The main physics principles in this lab are distribution of charge, electric forces, electric fields, and the use of Coulomb's law. In this video, I'll go through the main sections of my code with related physics equations and principles. Lastly, in this experiment, my final result is that I found the charge of the tapes to be roughly 2.3 times 10 to the negative 8 coulombs. I began my code by inputting my constants and observed values, which are from experiment 1. In my code, there are two functions which are called upon that work behind the scenes which I wanted to touch on. The first is the line charge function, which was provided to us. It creates a line of n point charges. The next function is the E-field function. This code simply calculates the electric field given the location of a particle and an observation location, using our known equation for the electric field of a point charge. Moving forward, I created two line charge objects, using the given line charge function to represent the two pieces of tape. I have the pieces of tape split into 10 point charge pieces. Next, I implemented scale factors so that we're able to visualize the objects more easily. Notice that the scales for the forces are equal. And I've additionally included that we know from experiment 1 that the electric force and gravitational force are of equal magnitudes, and therefore that the net force is 0 on the tape. The following nested for loops go through each of the 10 point charge pieces of the tape. The code first calculates the electric field on the top tape due to the bottom, represented by green arrows. The code then calculates the electric force due to the bottom tape pieces on the top tape pieces. As the code loops through each piece, the results from the pieces are summed to determine the net electric field and net electric force. This code represents the individual expressions for each piece and adding the contributions of all pieces as in our textbook procedure for the calculation of the electric field for distributed charges. Lastly, I created the arrows to represent the electric force and gravitational force, with the gravitational force magnitude equaling negative mg, as we know from Newton's second law. Then the code displays the results. Here's the image of my initial result from my code using the charge I found in Lab 1. You can see that the magnitudes of the arrows representing the forces are not equal when we know they should be. This indicated that the charge I found in Lab 1 is not accurate given the assumptions made in Lab 2. I manipulated the charge input until I found the magnitudes of both forces to be equal, as well as calculated the charge using integration, and found the final charge of the tape to be roughly 2.26 times 10 to the negative 8 coulombs. This is roughly 2.5 times larger than the charge I found in Lab 1. These estimates for charge between Lab 1 and 2 differ because they are based on different assumptions, with the assumptions and results from Lab 2 being closer to the real value, given that in the real world the charge would be distributed across the tape. In Lab 2, we are able to build on our knowledge from Lab 1 and apply the same key physics principles and equations to build a more accurate model using the key procedure we know for determining electric field with distributed charges.